even though like it was like a success for us, how many people actually get the name? So that wasn't like it was great, but it wasn't anything that we could actually publicly like other than sort of other than sort of technical knowledge.
And the thing that had was from the internet community on the email community as a pushback. They said, why do you want to do V6? You will still need to have a email address for sending email to everybody for the next 20 years to come. Because there's no other way, there's no gateway. Everybody has got an ID4, and the last one standing is ID4 address. You still have to be able to send the email the ID4. So I think I was crazy. But, in the email ecosystem, we are facing all different ways.
So to her point of Facebook's doing it, how much did you guys reach out to other tech in the community on their deployments? Like V6 originally with Will and Don, they were doing a list. I think they've evolved beyond that at this point. You guys so you get ideas on how you deploy
Content providers
or just network guys in general.
Yeah, so a lot of us were plugged into the community overall. I was involved in ISO days and Mongoose and so we kind of were already, sort of knew the challenges was kind of learning to apply with a lot of communication. We also plugged into what our security providers were doing and they were doing that stuff so that we can actually do it.
I wanted to ask, like, how heavy or how complex is it to have a security on the IPv6 compared to IPv4, or is it lighter on the security or is it really complex?
But wait,
Whoever touches the microphone to be muted, they actually. Oh, yes, thank you.
Testing. Okay. From the security side, actually, I think it's not exactly network security, but like application security side. So IPv6, we see it from two sides. So on one side, IPv6 can actually, because there's no network translation layer like IPv4, so it's easier to pinpoint, say, oh, this guy is bad. So it will not do something like block the whole linking network. Surprisingly, the whole linking network still has only one IPv4 address, public IPv4 address. So if one guy, say, inside LinkedIn behaves bad, the whole linking website, the whole linking network will be blocked. IPv6 solved that problem. But on the other side, we see two challenges. So first is, to identify one single person, it's more difficult on IPv6. The reason is IPv6, normally you actually got allocated like a big subnet instead of one single IP address. So how large is the subnet? Should we try to detect like abusers or hackers? So that's one question. The other one is actually IPv6 address. As of today, people are kind of easy to acquire new IPv6 addresses. It's cheaper than IPv4. So abusers can technically say, attack us using one block of IPv6 and then switch to the next block. So that's another challenge. So the third challenge would be the coverage of the geo that's actually related to block. So today there are a couple of IP to geolocation providers, but the data is very sparse because it's not like IPv4. IPv4 address is pretty much all allocated, right? So for IPv6, it's still being allocated. So it's basically we on a daily basis we see new blocks of IPv6 traffic coming in that maps to nowhere. So that's also create a new challenge to the security team, because security, the most reliable way is to map this to a geolocation and then use some other heuristic algorithms to figure out whether this is a attack, like group of attacks, or something else. So these are the challenges we are facing from the application side.
So I would like to add on the network side, it was straightforward. So on the production side, we allow only the services we host, like we allow HTTP, HTTPS, and mail. So we allow all those traffic to come in. And also we allow ICMP packets for error detection. And the host level also does an attack, like where you can have neighbor exhaustion. So we allowed only traffic to /120, so for 128. So basically we map the IPv6 address out of IPv4. We map in the V4 address, V4 address to the host side and used only the first 120 bits of the network. We allow only traffic to the first 120 bits. So in that way, we limited network which we open from the internet. So since we restricted what address is open and also restricted what service is open, we limit the traffic which can come into the network. So it was straightforward, exactly like I did before. There's not much difference on the security side.
Yeah, also on the security side, I remember we had a discussion of what's a real security risk, what's the safe security problem, or what's a future security problem. And the issue was to be able to say, okay, this is a future one. We don't need to be absolutely perfect. We'll tackle the problem as it comes nearer. Because otherwise, we'll design something that is perfect and never implement it. So we have to see that. I see also in the security, we have that. So things that may not be natural, that allow packet to be able to size a different packet. And also there was the so DNS fragmentation, IP fragmentation is needed for DNS if you want to do DNSSEC, if you start to have big reports. And on IPv6, it's a problem because you have to allow header flow next headers. So you have that to find some other strategy to be able to allow them when dealing with them. For the mail side, if you talk on security, so if you want to stop all the spam, the strategy is that you do domain blocking. So you're not looking at blocking per IP address, but on the domain blocking side. So you have to implement in your mail. You parse every domain that you can find in the email headers that are relevant to the sender, and if one is on the blocking list, you block the email. And the second part is to have mandatory domain authentication. So if you come on IPv6, I want to see SPF or key as a pass. Otherwise, I don't want this email. If you look at Google, Gmail, if you don't have SPF or key, your mail goes into the junk folder by default on IPv6. So people have discovered when they enable IPv6, so their mail was going into the junk folder by surprise. So as long as you mandate domain authentication and you do domain blocking, then you're already in a good spot and blocking of the spam itself.
I think that's true with Office 365 too, right? They have a default block policy if you don't have DKIM or SPF enabled for sending mail into Office 365 with V6.
So there's an organization which is called MOG, Mobile Anti-Abuse Group, all the people involved in mail, and there's a recommendation about what to do on mail and IPv6. And domain authentication is mandatory. So theory from Microsoft Office 365 implemented it. So there's different variation. The way they do it is that they don't bounce the emails, they will bring it in, but they define it so much that it's very usable.
So I think if you are thinking about application blocking, you have to figure out what you're comfortable with in terms of blocking, right? Like which IP space do you want to focus on? Because geolocation for data for all weather blocking is terrible. It just sucks. The vendors are really behind. So if you're working at scale, like we had to actually come up with a whole method of stuff. So I think that if you are working at a scale like or very like when very sort of in IPO content heavy products, then you have to think about a way you feel comfortable with what you consider sort of your level of blocking. You do have to write some amount of code on your side and you feel actually like she was saying, blocking on the edge side. So yeah, feel free to like ping us one of us after this and both community events if you want to sort of a much deeper topic to go into it. And the security experts there alongside the delegate here so we can use points.
So I'm sort of curious about how you guys are handling large-scale geolocation issues with mapping that sort of security posture when you're still developing, most companies are still developing what they want to do on a global addressing standpoint. I've got an allocation from Aaron, am I going to use that overseas or am I not? If I go to all the RIRs and actually get blocked the way I'm supposed to, how do I identify organizations? Is it purely based off AS? Is it based off a registry entry? Are you guys scraping that stuff? Because those become different sort of challenges because most people overseas operations are probably for data center purpose versus, or they may be strictly if they're running a lot of offices, just purely eyeballs that are looking. So do you have methodology that you thought about to detecting between the two? It's a service offering versus eyeballs watching what we're doing. Sort of differences in terms of how you classify traffic and what's interesting in V6, because that's already existed before today, right? We know, oh, that's all consumer, that's all Comcast, right? We know those are just eyeballs that are looking versus people that are actually providing data center. Oh, that's all AWS, that's going to be services that are delivered, right? Things like that. Has there been any discussion about?
So in the discussions that I've had with the geolocation providers, they have not really had very much to say about IPv6. They said that everything we've asked them, like, well, we have pretty low confidence in the accuracy of our data because there's just not enough of it. And when we ask them about their roadmap and when they'll have more and when they think it's coming next, they just don't have any answers. And
so how can they not have enough data given where things are at today?
Well, because I think, what is it, 3 to 4% of the internet traffic is on IPv6 today? 6. So it's, I think that.
Yeah, but it's a relatively small data set. It shouldn't take them that long.
But the thing is that I think what they're complaining about really is they're fine on the country level and maybe the AS level, but like a lot of people ask for like all level data, right? And that's where they're having a hard time because people are not just contributing back to it; they're putting up their real sort of information. I don't know, they're having huge challenges.
And the way they explain this to me is they have to do a little research on the IP addresses when they come in, and they're the more reputable firms, their confidence level is based on what level of research they've completed on the set of IPs as well. And so there's, I'll use that as an example. When IPv6, we told the provider we were using, we launched IPv6, these are our IPs, and the other providers didn't have that data because we didn't give it to them. And so, kind of bad on us. If you want your geolocation to be accurate, you should do that. And then also, at many companies, what they'll do is they'll collect data from their users, right? So if you have a LinkedIn account when you sign up, we ask you where are you located. If you have a mobile phone, for example, we can track your location. Our in-house security policies and our user agreements do not permit us to use that data for anything. And so we can't use that data, and so we rely on third-party information. But other companies do it a lot. And some of them even ask you in your browser, can you use your location from your desktop? And so they can have a lot more accurate data that way. And the geolocation companies kind of rely on data that gets fed into them and that they can then check. So it's a very interesting space. There's actually, on just IPv4 data, there's a company that we have a relationship with, unprompted, did an evaluation of different geo-IP providers on country, region, city, zip code level data. And for IPv4 data, it's not very good.
I'm not too surprised.
I think to answer your point, like, I think some of it is also when you ask like how come is it there? I don't think that's I think some of it is just they're behind. They're behind. They haven't invested the resources to do it, or to think that hey, now there's a new IP space that's going to be in the world in the next 5 to 10 years or whatever. They're not thinking that far. Right? That could be sort of one major difference. And also like a lot of the folks at scale, like Google, you go talk to them, they didn't even consider when they went into their own stuff, right?
Yes.
So I would do the same thing. So I think they're being more than me, right? But I think Miles and Craig side stressed that in order to make the impact for the rest of the world, I think the geo I think must happen, right? Because that's what makes it more difficult for other people. Like for example, the smaller sort of ads or ad startups, people who rely on this stuff a lot more, who will be the resources that they will have challenge.
I can give you an example of recently what happened was that we got like the data from the provider and the traffic, like we reported something saying this was not belonging to China and they kind of don't know about that. And then suddenly the next month onwards or the next week onwards, we started putting as Hong Kong because we got the feedback from someone and we updated the system to keep it as Hong Kong. And when we reported saying that this traffic shift happened, basically they went back and checked and said that whatever they did was sort of a mistake and they reported it. So still those sort of things are happening, and I think primarily they're getting feedback from the users or the consumers and investigating it and then allocating like this belongs to this country or this region.
Well, one of the things that benefited Google in figuring that out was pre-V6 day, not so much launch, was they were doing whitelisted DNS. And so I remember because, HE's guilty of breaking up 32 into 37s for all their worldwide pops, it's still inherent 32 at the core. You don't know that it's Frankfurt, IP space being used in Germany, for example. So when going through a player like Google, you're whitelisting, you're telling them the blocks that are there. So that way they know how to regionalize the content. So yeah, other players like MaxMind and stuff like that, they don't get that insight unless they go out and ask. They're not that often that I've seen.
Well, are you guys going to be putting up something similar to Google? There was a registration for your prefix to actually tell where it's geolocated, because Google was doing redirects. So Hurricane has some blocks that were tagged out as being. It's just sort of an interesting thing. So my kids were screaming down the hallway, "Dad, everything's showing up as Taiwan." Yeah, so it was all Chinese getting redirected. So I had to shut off my tunnel for a little bit until I got that fixed.
Google/NCR.
Yeah. So I mean, and Google was very quick on it. As soon as I sent an email off to Lorenzo and Eric, and they're like, "Oh, go to this link and register your prefix and tell us where you're located, and we'll flip you back so your content doesn't flip over." But I don't know. I don't know if that can be a community-driven effort or if it makes more sense to have individual companies that are doing it. How's that going to play out in the bigger ecosystem for you, for folks like yourselves, which are much more web scale focused providers?
We have to keep our very transparent, and we make sure that we have that equity reflects where they're going. So we think we do great with that. We think that other people should do a good job of that, and hopefully that's actually how it should work. So we don't want people doing the data control created so one thing that I wanted to add was sort of how bad this situation is. I'm part of the IETF, I saw the V6 measurements working group, and we were trying to figure out how do we measure V6 growth globally, right? So there's a bunch of us, content providers, ISPs, and a part of this working with me, like, a few times a day just to see how the growth is going. I think you see these numbers on the ISOC page, and the way we gather it is actually, it's very challenging because of this, right? You can't just say to somebody, says, hey, tell me how much V6 you see from this country or that country, because the data can be very skewed. So we pick very specific ASs that we've got permission from, and we kind of use that to say, okay, this is the growth of sort of the internet today, V6. So the AS level is the sort of source of truth, and that's where you find that you get the best sort of data from it, because at the network level you can get it. as well as the application. So AS was so I think sticking to the AS world is probably the best for right now, and the rest is awesome.
Yeah, I think that's how Cisco's doing it too, right? Alon with the Go 6 is all AS based.
I think for us also, we've got later guest traffic. So we've got an angle is logging in and it's telling us, in which language, which location he is, as part of the registration process. So it's not like a content provider where you only knows the IP and you have to provide the content in a specific location, language based on the IP or the browser settings. So it makes life easier for us to select the right content. You don't need necessarily to have to look at the IP. It's only for people arriving for the first time on LinkedIn and you want to present the page in the right language that they understand it. Otherwise, once they are in, they tell us the way they want the site to be.
Right. No more tough questions for me?
Okay. Do's, don'ts, funny anecdotes from your implementation deployment to V6? Lessons learned? Never to be repeated?
Anybody from it?
Yeah, so we took for granted that our TNS providers would treat IPv6 IPv4. They do not. And one of them, we operate using a lot of global load balancing tools, and one of them didn't do health checking and automatic failover on them. And because we have a pretty redundant environment, if we want to fail out of a site or something like that, we couldn't just take down health check. We actually had to touch DNS to do it for our providers. And yeah, we did check that. We just thought that they would have the same features.
Do they now, or did you roll elsewhere?
They don't now. They're better. They'll acknowledge a health check. It's just not as seamless as we'd like it to be. We can now do it via health check, but it's not as seamless as we
I think that we are trying to do a bit on V6, and okay, do we do a DSR? Yes, as a provider, we can do a DSR. Yes, we can do it. Okay, what's the config? Yes, we can do it. So I have to try various configuration between LATAM and I think it's supposed to make it work. What is the question on that? Fun one. Okay, that's how you do it.
And probably most of the V6 issues that have come up since we launched it come to my team because they end up very often being reported as latency issues. And my team addresses a lot of digging into why there's latency and figure out what we can do about it. And we've actually seen a number of routing issues for IPv6, and the routing will just be really strange, and it'll go, from Singapore from a user in Singapore to Japan, sometimes to the UK, and back to Singapore before it enters our office in Singapore. And I don't know why, and so to call the different peering providers we have and just say, hey, we've got this weird routing going on, and you maybe take a look as to why that is. And we've seen that actually more than one occasion with the CDNs. Their peering agreements will be because we don't control them, right? So we can just report to them, hey, users that are hitting the domain that we specifically sent to you is doing some very weird routing when we do trace routes for this specific edge. And they contact whoever that provider is, and it's magically fixed. But we've had it come up over and over, so they change things, and it's often due to a routing issue when we're seeing latency. And it's often user reported, right? Because you don't, a user will unfortunately tweet or something with the IPv6, and it's really, really slow. But if I switch to IPv4, it works great. What's going on with an IPv6?
So you're getting customer feedback via Twitter?
Yeah.
That's funny.
You guys get that too via Twitter?
the thing also I see on the email side, when you say dual stack, that's the wrong definition. It's two separate stack. Really, on emails, there's different type of parameter on IPv4 and on IPv6. One providers narrow like 10 connection per IP on IPv4, but 25 per IP on V6. So you have to really understand that, even if it's run on the same hardware, that's two different servers running on two different stacks, and they happen to communicate with each other. But you have to take it as totally as a network.
So the dual stack, having a dual stack, does it cause any challenges or is it still, is it a smooth road or how is it right now?
The question was
IPv6 and IPv4, since we still are, and many providers are not entirely IPv6 based, so we still have dual stack. So how best is it working in coordination, or is it really falling apart, or how is it?
So what also is that you have the selection of the IP address you want to connect to. So there's two levels of selection. The first one, which is the default, is the network level. So if you query and we say, well, I want to connect to this hostname, then by default you return IP as preference. But then your application may decide, I'm going to make the decision. So you see that on mail, and you see that on the web API calls, whatever you want to call it. So more and more, the application will make the decision where it wants to connect and not follow the network stack. And on mail system, then you've got MX pointing to hostname that points to A or quad A, so that makes a lot of different choice and capabilities. And not all the mail server were making the same decisions. So that was interesting.
So the question was on dual networks, right? So one thing I would say to use is dual networks, right? It's the easiest way to do it. Largely because you've got a pretty modern set of application support, right? Like you have probably the latest version of Linux running on it with any other sort of OA stack, right? Probably the hardest thing is right? And so sometimes people think that hey, maybe it makes sense to inside some code that there's a lot of systems, and then also just to solve the challenge of what you do these addresses inside your stack. So I would say that it's really but and then you get this also some what you do with most of us doesn't work very well. We do that is what the OS has support for sort of earlier enough or later enough how you look at it to have support for these things. But what happens to these things errors when you actually get considered right into your backend system? And that is what maybe actually have Chief talk a little bit about how we handle that problem, right?
Yeah, actually, so we decided, when we designed the whole system, we decided that all IPv6 traffic terminates at edge because the internal applications, first there were like hundreds of services that you need to operate and you need to understand. So that's why we decided internal network still is IPv4. But still, some of the internal services, because like security service, they have to understand the IPv6 address of a client. So our solution is actually when the edge load balancer terminates IPv6 address, we append a particular header to the HTTP request forwarded to the internal services, so that all the internal service will be able to, if they are interested, will be able to actually get IPv6 address of the actual client. So some of our service, like payment service, in order to do all kinds of like auditing and maybe potentially trace down who is doing the fraud charges. So we have to record those IP address. So those services has to be able to understand both the IPv4 and IPv6. And during our basic design phase, we decided, well, of course, we talked to other peers like Facebook and Yahoo. So we learned from their lessons. And then from the very beginning, we decided to store all IP address, regardless of V4 or V6, in the same format. And that format will be the binary format. So the binary format is the only unique format to represent an IP address. So for IPv4 address, we actually store them in the IPv4 mapped IPv6 address. And of course, for the native IPv6 address, we just store them natively. So from the edge, before they even enter our storage system, all IP address will be standardized. So that's why we can somehow separate the edge network with the internal network. So internal doesn't have to be IPv6 in order to understand the like the client IPv6 addresses and connections.
So basically, once that was done, from the data side, it was easy for us to basically say that we look at one particular value and we treat them the same. So we get both V6 and a V4 map out of V6, and we consume it that way all the way through till we go ahead and report it out. And that made it easy for us to even switch from the, so the existing, the current at that point in time, implementation was a string representation of the IP address, and it was IPv4 only. And as a conscious decision that was made on the application side, as G mentioned, there was a new data field that would have both the V4 map out of the V6 and the V6 natively itself, flowing through the entire pipeline. And we were basically looking, we had to write new basically UEFs and all that stuff to manipulate those because we were consuming a string and we had to switch to any binary format. And we ended up basically having that data all the way for our reporting as binary. And we had UEFs which would convert them into a string implementation or the rest of the other data. So that was like a, and then we didn't impact any of the existing systems because people slowly were missing out on the V6 information if they were looking at the old data field. And then they were basically gradually migrated over onto the new data field. And that was basically pretty easy for us to slowly migrate onto it as a big bang sort of approach to migrate everyone over to start using the new data.
So I have a question about that. Are you doing regular expression matching on the binary, or are you doing it on the string value sets? Where did you choose to actually do your match?
It switches between, again, like we start off with a binary, we end up in a binary, but in between we switch between string and a binary. So the geolookup stuff from the vendor that are provided, the vendor that we are using, only does a lookup on string field. So as and when the data is found, the site comes and lands and stores on our infrastructure. We basically have to convert it to a string to do a lookup to get the relevant information. And once we go ahead and get that information, we load that up into either a database or one of our own applications within LinkedIn. We convert that back into a binary.
And do you simplify your life from a regular expression standpoint of always having a fully uncompressed, no zero compression, no leading zero compression done, or and have a full string value set, or do you actually build more complex regular expressions that can actually identify zero compression and reduce leading zeros?
So what was storage?
So I can explain. So actually, we evaluated all kinds of solutions. So using regular expression to match the string was one of the options we discussed. But we feel like, if it's a string, that's first, IPv6 address, even if we guarantee that it's like no zero compressions whatsoever, prefix is always zero, all uppercase, even if we standardize it, somebody will make a mistake. Somebody will make a mistake. So it's because it's a string, there's no strict definition or validation. But if it's a binary array, nobody will make any mistakes because it's binary, nobody would be able to understand, and then they will look up what's the binary value would be look like. So that was one of the conscious decision we have. And the second one is if you use like a string representation, still it's kind of awkward to actually do some kind of prefix matching. So string value can do like byte level prefix matching, or if you count down granular, it can be like 4 bits. But still, you cannot do 1-bit level prefix, like /57. You cannot do that. So that's why we'd rather choose to have the binary representation in all our permanent storage, like database, Hadoop files, all are binary. But sometimes, because of different vendors, API designs, you want to be backward compatible. So internally, over the wire, it might convert that binary representation into a string in order to call some other service, or sometimes even third-party libraries. So that string representation is actually, we consider it as transient. So we don't store them permanently. So that's the decision we made.
And no zero compression, no leading zeros. You do
Right.
the full representation
Right.
in the string.
Right. So when we convert a byte into a string representation, we actually expand the whole thing. But when we convert a string into the byte, we accommodate everything. Zero compression is okay, leaving zero missing is okay, lowercase, uppercase is fine. We have to accommodate all different kind of format. But when you do the reverse conversion, we try to make it standardized. But we do ask our engineers not to persist that string. You can use it in memory, you can use it over the wire, but don't save it.
And there was another reason for doing that, because our security team wanted to, within database, they wanted to query the IPs. If it was stored as a string, they could not do range queries on that.
Right.
And they could not do partition based on that. So with this was one of their needs, which we had to, that made it like go towards binary representation all the way through.
Yeah, there's no natural representation of counting in hex in any database tools that I'm aware of. So it's a little hard to count in hex.
And believe it or not, we were storing IPs as string before, and they were not. They had to pull them out and do something before they could even use them. So that was a need that they had, and that's what the reason we had them as within the databases as well to represent as a binary.
Are slacks really being used? Slack IP address 586.
So is Slack actually being utilized? Do you guys utilize Slack at all, or are you all DHCP v6, or a combination? Or what's your ugly flavor of the week?
Today we use only the edges, so it's almost the static addressing on the front end. So we look at prefix to traffic key, and they look at the IP address, and the others. We allocated the prefix to the traffic chain, and they map the V4 into V6 on the host side. So it's straightforward addressing scheme.
What are you thinking about for your corporate inside when you're doing the deployment?
In the corporate, we use DHCP.
That's what you're going to stay on? So Android's just tough luck? V6 for Android?
Yes, delegation will work.
With PD?
Yeah.
Not for it. No. Doesn't have a DHCP.
So when Android doesn't support DHCP, like plain vanilla. It supports DHCP pref integration.
So where is your task force on doing your corporate enterprise deployment? I mean, you've talked production. And
Yeah.
what about the other flip side?
Yeah, so everyone in this side of the areas of production, right? So we do have a corporate team that has supported us when we were launching, like to get all the offices and wireless and everything online. They have a lot more to do on gone and asked them maybe start building or finding think about using space for V6, because largely we have a lot of offices that are globally coming across the world and one more devices and all that. So I think they have a problem, and they do have they're talking about it, but maybe
Yeah, sure. So while I'm on the production side as well, something I know about our corporate IT side is that as part of the production IPv6 rollout on the edge, they committed to rolling out IPv6 through all the engineering offices. So that's where they kind of drew the line and said, these are going to be our proof of concept sites and scope for IPv6 at LinkedIn. So after IPv6 was launched on the edge and let settle, they've been tuning that. So there is an internal initiative on the corporate IT side to roll that out to all of our offices, and just make sure that all of their builds can be done. It's more from a consistency standpoint and why would we buy up another office without taking into account that?
No. Are you using failover in the DHCP side? You said you're using failover most of the address.
Failover with a V6 connected to a V6 address.
No, the DHCP failover, sort of RSC. It's not quite an RSC, but it gets used in DHCP4. And I've always wondered if people are really going to use it in V6, or they're just going to say the address space is large enough. We're happy to just change addresses.
I don't know. I don't know.
On the corporate side also, I think that's something that we're looking at production and we did 6 in our most of the developers were at the time. That is a new one, and IPv6 address so that is needed to play with it and security. And that's also the financial security also because they needed to test the site with IPv6, so they needed to have them all the QA machine on IPv6, so they could set it up also. But also you are talking about DHCP, so the trouble on the corporate side is that if you use automatically created IP address and you don't have privacy, which is a problem for employees when they go inside the web, so you want to have randomized, but then if you have a security problem, you don't know who they are inside the network. It's a problem that apparently only DHCP can solve unless you put a sniffer on every switch that you have to know the combination between the MAC address and the IP address of the certain point in time. So DHCP is a little bit easier. If you want to trace, something internally and say, okay, so this IPv6 address at this time, who is it, which machine?
And I think certain forces will push them there eventually. Like we're actually thinking of our next step to do one of our data centers to do IPv6, maybe not that high thing, but at least how do we go about it because we know that scale is not the best challenges. So Paul sort of that on that perspective. And, there's that piece that probably drives the corporate to say how to employees access and management system that you have to make. So we trying to go down that route to see what do we do to run things maybe and not lose that anymore. Just because of the scale of the big case, and at some point we'll have to solve the problem. So look at
If you guys put any tools in place to help you debug happy balls, difference in behavior, difference in OS in terms of how things are accessing?
No, actually, that's something we think about, and we see a little bit of a challenge, but I think I haven't seen suggestions yet to work with that. I know I've talked to Facebook, they also have the same problem.
Right.
And largely we see like the big one is iOS support, right? Because of FFS,
is technically TJ's mailbox. It is not normally checked. You should not hear this